This is section 13.6, special products. And a couple things that you need to realize is that when we're multiplying two binomials, we can use a special thing called FOIL. So binomials, remember, are two-term polynomials. So for instance, a plus b and c minus d. So each of these is a binomial, and therefore we can multiply them using this special rule. The special rule really is just a means, it's an acronym for remembering how to multiply every term in each parenthesis times every term in the second parenthesis. So it's just a method for remembering your distributive property, which you learned in 13.5. So the first example, I actually write it out and I say, okay, we're going to take x, first term in our first parentheses, and multiply it times each term in the second parentheses. Then I'm going to take the second term, 5, and multiply times each term in the second parentheses. So what ends up happening is, by using FOIL, we're just remembering how to multiply, how to use our distributive property. So just let's look at what we're doing here. By multiplying x times x. So x times x, those are my first terms. This is my f. And then I multiply x times 7. So x times 7. So look at where your terms are in the binomials. We call these your outside terms. And so this is called O. Then you're going to multiply 5 times x. Notice where the 5 and the x are in your two terms, two factors. And again, we call these our inside terms. And then we're going to multiply 5 times 7. So 5 and 7 is the second term in each binomial, and we call these your last terms. So you're going to multiply your first, then your outer terms, then your inner terms, and then your last terms. It's just a little bit easier way of trying to remember how to distribute. Then going ahead and multiplying, x times x is x squared, x times 7 is 7x, 5 times x is 5x, 5 times 7 is 35. Then combine like terms, you should end up with x squared. The 7x and the 5x we combine together becomes 12x plus 35. And that is your answer. The next problem, I'm going to do the same thing. I'm going to write it the same way. Just make sure that we understand what we're doing. So it's y squared times each term in the second parentheses plus the second term on the first times y squared minus 2. And there's nothing wrong with writing out your multiplication like this every single time. If that was what you need to do, then that's what you need to do. So again, multiplying my first terms, which is y squared times y squared. So remember that when we're multiplying, we're going to add our exponents. So y to the 2 plus 2. That gives me y to the 4th. Then y squared times negative 2. Negative 2y squared. Then 1 times y squared gives me just y squared. 1 times negative 2 gives me negative 2. So the only time I needed to worry about my exponents was here when I was multiplying like terms. When I multiplied the y squared and the 2, there's nothing to do. They're not like terms. So then combining these two middle terms again, we're going to end up with y to the 4th minus y squared minus 2. This next one, again, I'm going to keep writing it out so that you understand the whole FOIL process. So 6y to the 4th times every term in that second parenthesis minus 2z to the second times 6y to the 4th minus 3z squared. Okay, so once again, I'm going to multiply my first terms together. That's these two guys. When I multiply those two together, 6 times 6 is 36. And then I have a like term here. The common base. When I have the same base, I'm going to add my exponents. So 4 plus 4 is 8. That's my f, by the way. Then I'm going to multiply my o's. So 6 times a negative 3 gives me negative 18. Y and z are not the same base, so I don't combine them. So it's going to be y to the 4th, z to the 2nd. And that's my o. Then I'm going to multiply my inner two terms. So that's going to be negative 2 times positive 6. So that's a negative 12. And again, the z and the y are not the same base, so I can't do anything with the exponents. And I'm going to write them in alphabetical order just so that we keep everything consistent. So y to the fourth, z to the second. So that was my inner terms that I was multiplying. And now I'm going to multiply my last terms. So 2z to the second times negative 3z squared. So that becomes a positive 6. Now I do have the same base. I'm going to add my exponents, which gives me z to the fourth. So now looking at this, can you see that the middle terms are the same? They have the same variables with the same exponents on them. So I can combine these two terms in the middle, and I end up with 36y to the 8th minus 30y to the 4th, z to the 2nd, plus 6z to the 4th. On this next one, I'm just going to try to use my FOIL method. So I'm going to write it out for you a little bit differently. So my f, so that means my first terms being multiplied together. That would be x to the 4th times 2x. My o, that is going to be outer, so that's going to be x to the 4th times 1. Then I'm going to be looking at my inner terms. So that's going to be these two terms. It's going to be negative 3 times 2x. And then I'm going to be looking at my last terms, which is going to be the negative 3 and the 1. So there's my FOIL. I'm going to go ahead and write out what I get. So x to the 4th times 2x. Well, that gives me 2x, same base, add your exponents. Remember, there's a 1 on that x there. So it becomes x to the 5th. Then I'm going to have x to the 4th times 1, which gives me x to the 4th. Then I'm going to have negative 6x. And then I'm going to have negative 3. Look for like terms. I don't have any. That is my answer. Okay, now we have the enviable fractions going on here. I'm going to try to do it the same way I did the previous problem. I'm going to have an f, an o. Okay, so my f, that's my first term, so that's x times x. O, that's my outer term, so that's x times 4/7. My inner terms, so that's negative 3/8 times x. And then my last term, so that's negative 3/8 times 4/7. Now I need to play around a little bit with this. So what do I end up with? I have x squared plus, I'm going to put the 4/7 in front of that x, minus 3/8 x. And here I'm going to end up with negative something. I'm noticing that I have a common factor here between my 4 and my 8. I have a common factor of 4. So 4 goes into 4 once, 4 goes into 8 twice. So simplifying that, I end up with negative 3 times 1, over 2 times 7, which is 14. I notice that the middle terms have the same variable, so that means I'm going to combine my coefficients, and to be able to combine these coefficients I need a common denominator. So that's what I'm going to work on right now, is the common denominator for 4/7 and 3/8. And I'm looking at that and I say that the common denominator is 56. So 4/7 is going to be made into a new fraction where 56 is my denominator. And 3/8 is also going to be made into a new fraction where 56 is my denominator. 7 times 8 gives me 56, so I need to multiply 4 times 8, and that gives me 32. 8 times 7 gives me 56. I need to multiply 3 times 7, which is 21. So now I'm going to use these equivalent fractions and rewrite x squared plus 3256x minus 2156x minus 3/14. So now that I have the same denominator, I'm going to just combine the numerators. X squared and 32 minus 21 gives me 1156x minus 3/14. And that is your answer for this problem. This next problem, again, we're going to still be doing the same process here until you understand what it is that we're doing with our F, O, I, and L. So F, first terms together, H times H. O, that's your outer terms, H times 7Q. Inner terms, negative 7Q times H. Last terms, negative 7Q times positive 7Q. So now multiplying, H times H is H squared. H times 7Q, I'm going to write this in alphabetical order, so it becomes plus 7HQ. Then this next one, again, I'm going to write it in alphabetical order. It will be a negative 7HQ. And then the last one, negative 7 times 7 is 49, and it's going to be a negative 49. Q times Q is Q squared. Notice my middle terms. Again, if you write them in alphabetical order, it makes it easier to see if you have like terms. We do. We have an H and a Q in each of them. One's positive and one's negative. They cancel each other out. And we're left over with H squared minus 49Q squared. And that actually brings up the next section. What we have done right here is the product of a sum and a difference. So look at this right here. This particular binomial we're adding, that's a sum. This binomial we're subtracting, that's a difference. So what we have here is the sum of two terms being multiplied by the difference of two terms. So when you have the sum and difference of two binomials, notice what happened to our middle term. It disappeared. That's nice to know. So when you're multiplying and you have exactly the same terms, the only difference is the sign between those two terms. The middle term cancels out, and all you're concerned about is multiplying the first terms and the last terms. This is called, by the way, the answer that you get, the difference of two squares. There is no middle term. Okay, the next one is another special product, and it's called the square of a binomial. So notice that we have a plus 4 times a plus 4. I could have simplified this by writing a plus 4 quantity squared. And same thing over here with this one. I could have simplified it by writing a x minus 3 quantity squared. What I wanted you to see was a plus 4 quantity squared. You need to write that out. You need to simplify or expand it. So we're going to FOIL. First terms is going to be a squared. Outer terms is going to be a times 4, which is 4a. Inner terms is going to be 4 times a, which is 4a. Last terms is going to be 4 times 4, which is 16. Then simplifying and combining my like terms, a squared plus 8a plus 16. Over here, first terms, x times x, x squared. Outer terms, x times negative 3, negative 3x. Inner terms, negative 3 times x, which is another negative 3x. And then last terms, negative 3 times negative 3. Combining like terms, x squared minus 6x plus 9. So we have a rule down here, but I want you to see what happened up here. Notice your first term is just squared. In each of the, so if you were just given this binomial, your first term is squared. The second term, that's going to be squared and it's going to be added. And this middle term, if you multiply these two guys together, you get 4a, and then if you double it, you get 8a. Over here, if you take your first term and square it, if you take your second term and square it, remember a negative times a negative gives me a positive 9. And then the middle term is going to be, when you multiply these two together, you get negative 3x and double it. So that's what it's saying down here. if you have a sum or a difference that we're squaring, so you're squaring a binomial, I suggest that you expand it out, FOIL it like you normally would. Eventually you need to realize that it develops into a special kind of trinomial called a perfect square trinomial. And you want to realize that so that when you get into your next class, you know how to work backwards and find these two factors. Okay, on the second page, that shouldn't be there. On the second page, we're going to be using some of the principles that we had on that first page, those special products. So what I want you to see is that you have a sum and a difference here, and you have exactly the same terms in each binomial. So if you didn't have exactly the same terms, we couldn't do anything special, but we do. So this is called the sum and the difference. I'm going to go ahead and multiply it out using FOIL, which you can always resort to. There's no problem with that. But this is a special case. It's called the sum and difference of two binomials, and my middle term should drop out. So first terms, p times p. Outer terms, p times -2. Inner terms, 2 times p. Last terms, 2 times -2. P times p is p squared minus 2p plus 2p minus 4. Notice your middle terms, and you're left over with p squared minus 4. So we don't need to worry about the middle terms. We just had to multiply p times p and 2 times -4. This is the square of a binomial. Expand it out. W plus 7 times w plus 7. Using FOIL, w times w, first terms, w squared. Outer terms, w times 7. That's a 7w. Inner terms, 7 times w. 7 times 7 is your last terms. 7 times 7 is 49. Combine like terms, w squared plus 14w plus 49. Notice that my first term squared, my last term squared, and the middle term is found by taking 7 times w and doubling it. So we've performed the square of a binomial correctly. Okay, notice we have the same terms in each of these binomials. I have the same terms, one's positive, one's negative. That means that I have the sum and difference of two binomials. So I don't need to worry about my middle term. It's going to drop out. All I'm going to multiply are my 4u's together and my negative 9v times 9v. So I'm going to have 4u times 4u, and then I'm going to be multiplying negative 9v times 9v. So 4u times 4u is 16u squared minus 81v squared. I didn't have to worry about the middle term because I have the sum and difference of two binomials. So I didn't even bother multiplying them out. If you aren't feeling comfortable with that, go ahead and multiply it out, and then you'll find that they cancel each other. Over here, again, I have the same terms in each of my binomials. One's positive, one's negative. That means I have the sum and difference of two binomials. All I have to do is worry about my first terms being multiplied and my last terms being multiplied. So I have x squared times x squared minus 2 times 2. Remember, when you have the same base, add your exponents. X to the 4th minus 4. We have a squared binomial here. Again, write it out before you square it. This will prevent you from making a mistake. I would multiply it out using FOIL the way that we're used to doing that, and then I would double check to see if it is the square of a binomial, and it follows the pattern. So first term, 7t times 7t. 7 times 7 is 49. T times t is t squared. Outer terms, 7t times negative 6w. So 7 times negative 6 is negative 42. And then I have a t and a w. Inner terms, negative 6 times 7 gives me a negative 42. And I'm going to make sure I write this in alphabetical order, t times w. outer terms, last terms. Negative 6 times negative 6 is a plus 36, and then w times w is w squared. So I end up with 49t squared. Negative 42 gives me a negative 84 tw plus 36 w squared. And then just go back and check. Is my first term, is this what I get when I square it? Yes. My last term when I square it? Yes. And my middle term should be the multiplication of these two, which gives me negative 42 tw. Again, I'm going to write out an expanded notation, 2a minus 1/5 times 2a minus 1/5. First terms, 2a times 2a gives me 4a squared. Outer terms, I'm going to actually write this one down. It's going to be 2a times negative 1/5. Then I'm going to have negative 1/5 times 2a. And then I'm going to have a negative times a negative with it's a positive, and 1/5 times 1/5. The 2a's, if it helps, I'm going to write it over 1. So I end up with 4a squared. 2a times negative 1 gives me a negative 2a. 1 times 5 is 5. I end up with a negative, again, 2a over 5. And then 1 times 1 is 1 over 25. Combining my middle terms, I'm going to end up with 4a squared. I have a common denominator, that's good. I have a negative 2a and another negative 2a. That gives me a negative 4a over 5 plus 1/25. This particular problem doesn't have any special products to it at all. So I'm just going to go ahead and need to FOIL. 3a times 4x squared. 3x times 4x squared. Then 3x times 5. So I'm writing this out so you can see the multiplication. 2 times 4x squared. 2 times 5. So this is my f, just doing it horizontally, my o, my I, and my L. Simplifying 12. Remember to add your exponents. There's a 1 on this x, so it becomes x to the third plus 15x plus 8x squared plus 10. And then you want to make sure that you always write your answers in descending order. Notice this is not in descending order right now. So I'm going to start with 12x to the third. The next term should be 8x squared, then 15x, and then 10. There's nothing else we can do with that one. This one over here, we have the sum and difference of two binomials. They have exactly the same terms. In each binomial, the only difference is one is added and one is subtracted. So all I need to worry about is 2x to the third times 2x to the third, my first term's being multiplied, and my last term's being multiplied. So 2x to the third times 2x to the third. So 2 times 2 is 4x, and then I have the same base. I'm going to add my exponents. 3 plus 3 is 6. Then I'm going to multiply 0.3 times 0.3, and that gives me 0.09. And that is your answer to this one. Again, we don't need to worry about the middle term. If you want to multiply it out and then cancel it, that's fine. Okay, down here we have 6x squared, and we're just going to use our distributive property. So we're going to have negative 6x squared, and we're going to multiply times x to the third, and we're going to distribute. We're going to have a negative 6x squared times 8x. Then we're going to have a negative 6x squared times a negative 9. I'm just writing it out so you understand the distribution. So this becomes negative 6x, 2 plus 3 is 5. Negative 48x, 2 plus 1 is 3. Negative times a negative gives me a positive. 6 times 9 gives me 54x squared. You are done with this one. And then on this one over here, again, you make sure that you multiply each term in the first polynomial by each term in the second. We can't use FOIL on this because we don't have a binomial here. So you need to take y and multiply times each one of your terms in that second polynomial. And then you're going to need to take 5 and multiply times each term in that second polynomial. Multiplying out, y to the third minus 5y, y times y is squared, plus 25. When I go to multiply the second binomial, I'm going to try to line up like terms. So I have a positive 5y squared. I'm going to write that under my y squared term I have here. Then I'm going to have a negative, oops, this should have been a y here. Then I'm going to have I'm going to have a negative 25y. And then 5 times 25 gives me 125. Since I lined up my like terms, I can see right away that these guys are going to cancel out, and these guys are going to cancel out. And I'm going to just be left over with y to the third plus 125. These last two problems, I just wanted you to see the difference between them. So what many students do is when they see a binomial squared, they instantly say, oh, this is my answer. I'm just going to square each of the terms. So let's look at what we do here. Following my order of operations, it says I should simplify inside the parentheses first. So 6 plus 7 is 13, and then I'm going to square it. And 13 squared is 169. Do I get the same answer over here? So, is 6 plus 7 the same as 6 squared plus 7 squared? Can I take that square and bring it into the parentheses and get the same answer? Well, 6 squared is 36, and 7 squared is 49. 36 plus 49 gives me 85. Are they the same answer? No. Therefore, if you're given a plus b and told to square it, do not, bad, write it as a squared plus b squared. It is not the same.